Today, I'm going to tell you about something that has astronomers around the world both excited and deeply puzzled. A visitor from another star system, an object that traveled through the darkness of interstellar space for millions, perhaps billions of years, only to arrive in our cosmic neighborhood right now. This is the story of 3I Atlas, the third confirmed interstellar object ever detected. And what makes this one different is that it's behaving in ways that challenge everything we thought we knew about comets. But here's where it gets interesting. While most scientists insist this is just a natural comet, one prominent Harvard astronomer is asking a question that many are afraid to voice out loud. What if it's not? What if this visitor from the stars is something else entirely? Something that was sent here deliberately? Now, before you click away thinking this is just another conspiracy theory, I want you to hear the facts. Real data from NASA, the European Space Agency, the Hubble Space Telescope, and dozens of observatories worldwide. Because what's happening with 3I Atlas is genuinely strange, and by the end of this video, you might find yourself wondering the same thing that Professor is wondering. So stick around, because this story has more twists than you'd expect. And if you're fascinated by mysteries from beyond our solar system, make sure to hit that subscribe button and turn on notifications, because 3I Atlas is still out there, still moving, and still surprising us with new discoveries almost every single day. So what exactly is 3I Atlas? Let's start with the basics. On July 1st, 2025, an automated telescope in Chile, part of the Atlas project, which usually hunts for dangerous asteroids that might threaten Earth, spotted something unusual. At first, it looked like just another faint star. Magnitude 20. That's incredibly dim. You'd need a powerful telescope just to see a tiny dot. The object was roughly 4.5 billion kilometers from the Sun, drifting through the outer solar system. But when astronomers calculated its trajectory the very next day, they realized something remarkable. This wasn't an asteroid bound to our Sun. The path was hyperbolic, not elliptical. And that mathematical difference means everything. An elliptical orbit keeps you trapped in the solar system, looping around the Sun again and again. A hyperbolic trajectory? That means you came from somewhere else, and you're just passing through. On July the 2nd, 2025, the Minor Planet Center made it official. This was an interstellar object, only the third one we've ever confirmed. The first was Oumuamua back in 2017, a strange cigar-shaped thing that sparked its own debate about whether it might be artificial. The second was Comet 2I Borisov in 2019, which behaved like a completely normal comet and didn't cause nearly as much controversy. And now, we have 3I Atlas, the latest visitor, the newest mystery. Initially, scientists thought it was just an asteroid, a chunk of rock and ice ejected from some distant planetary system billions of years ago. But as weeks passed, and more telescopes turned their attention to this traveler, they started seeing signs of activity. A small fuzzy cloud surrounding the core, a short tail. This wasn't a dead rock. This was a comet. Water ice and other frozen materials were starting to vaporize as the object got closer to the Sun, creating that classic cometary glow. And that's when things started to get really interesting, because 3I Atlas wasn't behaving quite like other comets. Its brightness was unusual. Its trajectory was almost too precise, and it wasn't showing the kind of early gas emissions that most comets display when they start warming up. It was almost as if something about this object was different from the comets we're used to studying. The name itself tells you its story. The C in C2025N1 stands for a non-periodic comet, meaning it doesn't orbit the Sun on a regular schedule like Halley's Comet. The 2025 tells you when it was discovered. N1 means it was the first object found in the first half of July, during what astronomers call period N. And Atlas? That's the survey that found it. But the more important designation is the 3I in 3I Atlas. That I stands for interstellar, the third interstellar object humanity has ever identified. Think about that for a moment. In all of human history, we've only confirmed 3 objects that came from beyond our solar system. 3. Out of millions of asteroids and comets we've cataloged, only 3 have made the journey from another star. That alone makes 3I Atlas incredibly special. But what makes it even more intriguing is its size. Early estimates suggest the nucleus, the solid core of this comet, could be anywhere from 0.6 to 5.6 kilometers in diameter. That's huge for an interstellar object. If it's on the larger end of that range, it would make 3I Atlas one of the biggest visitors from another star system we've ever detected. And size matters here, because larger objects can survive longer journeys through space. They're harder to destroy. They're more stable. They can carry more information about where they came from. And this thing is moving fast. About 210,000 kilometers per hour. That's roughly 30 kilometers every single second. To put that in perspective, that's about 70 times faster than a bullet from a high-powered rifle. This is the kind of speed you only get when you've been flung out of a planetary system by gravitational interactions with giant planets, or possibly even by a close encounter with a passing star. Whatever happened in its home system, it was violent enough to send this object hurtling into the galaxy, never to return. Now here's the part that really captures the imagination. This object has been traveling through the cold, dark emptiness of interstellar space for an unimaginable amount of time. Millions of years, at the very least. Possibly billions. During that entire journey, it received almost no warmth, almost no light. Just the faint glow of distant stars and the constant bombardment of cosmic radiation. It drifted alone through the void, moving at speeds we can barely comprehend, until finally, by pure chance, its trajectory brought it into our solar system. And we almost missed it. If the Atlas telescope hadn't been scanning that exact patch of sky on that exact night, 3I Atlas would have slipped past us completely unnoticed. We would never have known it was here. Think about how many interstellar visitors might have already passed through our solar system without anyone ever seeing them. How many came and went before we had telescopes? How many are too small or too dark for us to detect even now? This raises an important question. If interstellar objects like 3I Atlas are so rare, or at least so rarely detected, what does that tell us about the galaxy? How many rogue comets and asteroids are drifting out there in the darkness between stars? Some scientists estimate there could be trillions of these orphaned objects, cast out from their home systems, and now wandering the Milky Way forever. Every single one of them carrying secrets about the star system where it formed. Every single one a time capsule from a distant corner of the galaxy. And that's exactly why astronomers are so excited about 3I Atlas. It's not from here. Whatever gases it releases, whatever minerals make up its surface, whatever chemical signatures we can detect, they all come from a completely different stellar environment, a different star, different planets, different conditions. By studying this comet, we're essentially getting a free sample delivery from another solar system. We didn't have to send a probe on a 1,000-year journey to another star. The sample came to us. But there's another reason why 3I Atlas has captured so much attention, and it's not just scientific curiosity. It's the nagging question that keeps coming up in press conferences, in research papers, and in late-night discussions among astronomers. Is this really just a comet? Or could it possibly be something else? Now, I know what you're thinking. Here we go with the alien spaceship theories. But hold on. This isn't coming from random people on the internet. This question is being raised by serious scientists with serious credentials, and they're pointing to real observations that don't quite add up. So before you dismiss it entirely, let me tell you what happened next. Because what scientists discovered as 3I Atlas got closer to the sun was something nobody expected. Stay tuned, because in the next part, we're going to dive into the controversy. The debate between mainstream astronomy and one very outspoken Harvard professor who thinks we might be making a huge mistake by assuming this is just a natural object. You won't believe what the telescopes revealed. So here's where our story takes a dramatic turn. Because while most of the scientific community was celebrating the discovery of this rare interstellar visitor and preparing their instruments to study it, one voice stood out from the crowd with a very different interpretation of what we were seeing. That voice belongs to Professor Avi Loeb, chair of Harvard's astronomy department, and he's not just some fringe theorist. This is someone who has published hundreds of peer-reviewed papers, advised NASA, and trained an entire generation of astronomers. And he's looking at the same data as everyone else and coming to a very different conclusion. From the moment 3I Atlas was discovered, Loeb started asking uncomfortable questions. Questions that made his colleagues nervous. Questions that made headlines around the world. His main point? The behavior of this object doesn't quite match what we'd expect from a natural comet. And if we're being honest scientists, we should at least consider the possibility that it might be something else. Let's look at his arguments, because they're actually quite compelling, even if most astronomers disagree with his conclusions. First, there's the unusual brightness. When 3I Atlas was first detected, it was exceptionally bright for an object at that distance. Natural comets typically don't become active until they get much closer to the sun. The heat from sunlight needs to penetrate deep enough into the ice to start vaporization. But 3I Atlas seemed to be glowing before it should have been, almost as if it had some other source of energy. Second, the trajectory. Loeb pointed out that the path this object took through our solar system was remarkably precise. It came in at just the right angle, at just the right speed, following a course that would take it close enough to the sun to be observable, but not so close that it would be destroyed. Now, you could argue that's just coincidence. Billions of comets get ejected from planetary systems, and eventually some of them will pass through ours with trajectories that happen to be convenient for observation. But Loeb asks, what if it's not coincidence? What if something chose that path deliberately? Third, and this is what really got people's attention, there was the lack of early obvious gas emissions. Most comets start outgassing well before they reach the inner solar system. You see jets of gas and dust erupting from their surfaces as the ice heats up. But 3I Atlas was oddly quiet in its early approach. It was bright, but it wasn't behaving quite like a typical comet should behave. It was almost too stable, too controlled. Loeb went even further. In September, when more detailed observations came in, he noted the unexpected stability and high mass of the object. If 3I Atlas really did change course slightly during its close approach to the sun, and early data suggested it might have, then something had to push it. With natural comets, that push comes from gas jets. Frozen material vaporizes on one side more than the other, creating a rocket effect that nudges the comet in a particular direction. But what if the mass was too high for that explanation to work? What if the trajectory shift required more force than natural outgassing could provide? That's when Loeb started talking about the possibility of technological propulsion, not just as a wild idea, but as a hypothesis that deserved serious consideration. He wrote in his blog, and I'm paraphrasing here, that if an object changed its course near the sun, but didn't show the expected level of gas emission to account for that change, then we might need to consider that the acceleration came from something artificial, a propulsion system, maybe even a solar sail using the sun's radiation pressure. He even made what some considered a provocative joke. He suggested that people might want to take time off work around October 29th, when the comet would reach perihelion, its closest point to the sun, just in case it turned out to be something far stranger than expected. Now, obviously, he was being somewhat playful there. But the underlying point was serious. We shouldn't assume we know what this object is just because it looks like a comet at first glance. The scientific community, predictably, pushed back hard. NASA, the European Space Agency, and astronomers at dozens of institutions around the world examined the same data and came to very different conclusions. And to be fair, they have strong evidence on their side. The Hubble Space Telescope got some beautiful images of 3I Atlas, and what did they show? A classic cometary coma. A fuzzy cloud of gas and dust surrounding the nucleus, exactly what you'd expect from water ice and other volatiles vaporizing in sunlight. NASA's SPHEREx mission, designed specifically to study the composition of celestial objects in infrared light, analyzed the spectrum of light coming from 3I Atlas and found signatures of carbon dioxide, water vapor, and other common cometary materials. Nothing unusual. Nothing that couldn't be explained by natural processes. Even more convincingly, the Mars orbiters got in on the action. In early October, when 3I Atlas passed relatively close to Mars, about 30 million kilometers away, the European Space Agency's Mars Express and ExoMars Trace Gas Orbiter both captured images of the comet. And what they saw was completely consistent with a natural comet. A faint glow, a developing coma, and absolutely no signs of any kind of artificial structure or unusual energy emissions. Then came one of the most important observations. In early October, NASA's Swift Observatory, which is normally used to study gamma-ray bursts and other high-energy phenomena, turned its instruments toward 3I Atlas and detected water vapor. This was huge. It was the first confirmed detection of water vapor from an interstellar comet. And that's exactly what you'd expect from a natural object made of ice and rock that formed in another planetary system. Water is everywhere in the universe. It's one of the most common molecules. Finding it in an interstellar comet is about as surprising as finding sand at the beach. The mainstream scientific consensus solidified around a straightforward explanation. Yes, 3I Atlas is special because it's interstellar. Yes, it's behaving somewhat unusually in certain ways, but unusual doesn't mean artificial. It means we're seeing a comet that formed under different conditions than the comets in our own solar system. Different chemistry, different structure, different behavior. That's exactly what makes it scientifically valuable. But then something happened that reignited the debate and sent social media into a frenzy. On November 10th, a radio telescope in South Africa, the Meerkat Array, detected radio emissions from 3I Atlas, and the internet absolutely exploded. Was the comet sending signals? Was this proof of what Loeb had been saying all along? Were we witnessing first contact? The answer, unfortunately for anyone hoping for aliens, was far more mundane. But it's still fascinating from a scientific perspective, so bear with me. What Meerkat detected wasn't a modulated signal carrying information. It was natural radio continuum emission at very specific frequencies, around 1665 and 1667 megahertz to be precise. And if you know anything about radio astronomy, you'll recognize those numbers immediately. Those are the characteristic frequencies of hydroxyl radicals, OH molecules, which form when water molecules break apart under intense sunlight. This happens with comets all the time. When a comet gets close to the sun, ultraviolet radiation hits water molecules in the coma, splitting them into hydrogen and hydroxyl. Those hydroxyl molecules then emit radio waves at very specific frequencies as they transition between different energy states. It's completely natural. It's been observed in comets since the 1970s. There's nothing artificial about it, no intelligence behind it. It's just chemistry and physics doing what chemistry and physics do. But here's what made this detection special. This was the first time anyone had detected these hydroxyl emissions from an interstellar object. With Oumuamua, we never got a chance because it was already leaving the solar system by the time we realized what it was. With Comet Borisov, it didn't pass close enough to the sun to generate strong emissions that we could detect with radio telescopes. But 3I Atlas, it came close enough, got active enough, and we had the right instruments pointed at it at the right time. So we got the data. And what does that data tell us? It tells us that the water in an interstellar comet breaks down exactly the same way as water in a solar system comet. It tells us that the chemistry is universal. It tells us that despite coming from a completely different star system, despite spending millions or billions of years drifting through the cold of interstellar space, this object is made of the same stuff as our local comets. That's actually profound. It suggests that the building blocks of planetary systems, the ices and rocks and organic molecules that eventually clump together to form planets, and maybe even life, those building blocks are the same throughout the galaxy. But it also tells us something else. It tells us that there's a natural explanation for the radio emissions. We don't need to invoke alien transmitters or communication systems. The comet is just doing what comets do. It's outgassing. It's breaking apart water molecules. It's glowing in radio frequencies because of basic chemistry. Professor Loeb, to his credit, acknowledged the radio observations, but maintained his position that we shouldn't rush to conclusions. He pointed out, quite correctly, that detecting natural radio emissions doesn't prove the object is entirely natural. A hypothetical alien probe could have a layer of ice on its surface, picked up during its long journey through space, and that ice could outgas just like a comet. You'd see all the same signatures: water vapor, hydroxyl radicals, carbon dioxide, but underneath, there could still be something artificial. Now, at this point, you might be thinking, this sounds like moving the goalposts. And maybe it is. But Loeb's larger point is worth considering. He's not saying 3i Atlas definitely is an alien spacecraft. He's saying we shouldn't automatically assume it isn't just because it shows some comet-like properties. We should keep an open mind. We should gather as much data as possible. And we should be willing to consider explanations that might seem unlikely, because the universe has surprised us before. And honestly, he has a point. Think back to Oumuamua. That object was so weird that even mainstream scientists entertained the possibility, however briefly, that it might be artificial. Its shape was bizarre, elongated like nothing we'd seen before. Its trajectory was strange. It showed a slight acceleration that couldn't be explained by gravity alone and didn't seem to match typical cometary outgassing. Even now, years later, there's still debate about what Oumuamua actually was. Some scientists think it was a hydrogen iceberg. Others think it was a fragment of a planet torn apart by tidal forces. Nobody really knows for sure. So when Loeb looks at 3i Atlas and says, let's not be too quick to dismiss alternative explanations, he's drawing on the lesson of Oumuamua. We were surprised once. We could be surprised again. But the evidence, at least so far, strongly suggests that 3i Atlas is exactly what it appears to be. A comet. A natural object. A chunk of ice and rock from another star system that got kicked out into interstellar space and happened to pass through our neighborhood. The water vapor, the hydroxyl radicals, the carbon dioxide, the structure of the coma. Everything we've observed matches what we'd expect from a comet. An unusual comet, yes. An interstellar comet with chemistry that reflects a different environment. Absolutely. But still, fundamentally, a comet. And you know what? That's actually more exciting in a way than if it were an alien probe. Because what we're learning from 3i Atlas is that planetary systems throughout the galaxy work in similar ways to ours. They form comets. They eject those comets through gravitational interactions. Those comets wander the galaxy, and occasionally they visit other star systems. We're witnessing a natural process of material exchange between stellar neighborhoods. Over billions of years, how many comets have been swapped between stars? How much organic material? How many water molecules? How many of the chemical precursors to life have been delivered from one system to another? 3i Atlas might not be a spacecraft, but it's still a messenger. It's carrying information about where it came from. And if we're patient, if we study it carefully, it can teach us things we could never learn any other way. But the story doesn't end here. Because as 3I Atlas continued its journey toward the sun, it started doing something that comets aren't supposed to do. Something that baffled even the astronomers, who were certain it was natural. It started changing colors. And not just once. Multiple times. In ways that nobody could quite explain. And that's where we're going next. So let's talk about something really strange. Something that even the most experienced comet researchers found puzzling. 3I Atlas started changing colors. Now, comets can show different hues depending on their chemical composition and activity level. But what happened with this interstellar visitor was unusual even by those standards. It went through a sequence of color transformations that left astronomers scrambling for explanations. When 3I Atlas was first discovered back in July, it appeared reddish. That's actually not uncommon for distant comets. The red color typically comes from organic compounds on the surface, complex carbon-based molecules that have been altered by cosmic radiation over millions of years. Think of it like a sunburn, but instead of UV light from our sun, it's high-energy particles from interstellar space slowly cooking the surface chemistry. So, red made sense. It told us this comet had been wandering through the galaxy for a very long time. But then, in September, something changed. Around September 20th, astronomers started reporting that 3I Atlas had developed a mysterious green glow. Not just a slight tint, but a noticeable, almost eerie green color that showed up clearly in photographs. And this got everyone's attention because green comets are special. The green color in comets usually comes from diatomic carbon, C2 molecules, and sometimes cyanogen, CN. These molecules form when sunlight breaks apart larger organic molecules in the comet's coma, and they emit a distinctive green fluorescence. So the appearance of green made sense in a way. The comet was getting closer to the sun, warming up, releasing more gas, and creating conditions where these glowing molecules could form. But here's what was weird. The transition from red to green was remarkably abrupt. Most comets show a gradual shift as they approach the sun. 3I Atlas seemed to flip a switch. One week it was reddish. The next week it was glowing green. That's unusual. That's the kind of thing that makes astronomers wonder if there's something different about the internal structure or composition of this object. Professor Loeb predictably suggested this could be another hint that we're not dealing with a typical comet. He pointed out that a color change could indicate a change in surface activity, and maybe, just maybe, that change wasn't entirely natural. Most scientists, equally predictably, said, "Hold on, there's nothing here that requires exotic explanations. Different layers of the comet might have different compositions. As the outer layers vaporize, you expose deeper material with different chemistry. Color changes are expected. They're just happening faster than we usually see." But then the comet did it again. In early November, specifically around November 4th, new images started showing that 3I Atlas had changed color once more. This time, it was turning blue. Blue. Comets rarely appear blue, and when they do, it's usually because of ionized carbon monoxide, CO+, or other ionized gases. This happens when solar wind, the stream of charged particles coming from the sun, slams into the comet's coma and strips electrons from the gas molecules. Those ionized molecules glow blue. So now we had a comet that went red, then green, then blue. 3 distinct colors over the course of just a few months. And scientists were genuinely puzzled. Not in a, "oh my god, it's aliens" kind of way, but in a, "wow, this is really interesting chemistry" kind of way. What kind of comet shows this sequence of color changes? What does it tell us about the internal structure, about the composition, about how interstellar comets differ from the ones that formed in our solar system? One theory was that each color represented a different layer of the comet being exposed and vaporized. The red surface was the radiation-processed outer crust. The green layer underneath contained pristine organic materials that had been protected from cosmic rays, and the blue innermost region might have been rich in carbon monoxide ices that only started vaporizing when the comet got really close to the sun and the heat penetrated deep enough to reach them. Like peeling an onion, each layer revealing something new. Another theory focused on changing activity patterns. Maybe the comet was having outbursts, sudden releases of gas from particular regions on its surface. If different regions had different compositions, you could get rapid color changes as the activity shifted from one area to another. Some comets do this. They have active regions that turn on and off as the comet rotates, and as different parts get heated by the sun. But the most intriguing possibility, at least from a scientific perspective, was that the color changes were telling us something fundamental about how this comet formed and what conditions were like in its home star system. The red organics suggested a surface that had been processed by radiation for millions of years. The green diatomic carbon suggested the presence of complex carbon chains, the building blocks of organic chemistry, and the blue ionized gases suggested volatile ices, maybe from the outer reaches of a planetary system where carbon monoxide can condense. Put it all together, and you have a comet that might be giving us a layered history lesson. Each color a chapter in its billion-year story. Now, if the color changes weren't enough to keep astronomers busy, 3i Atlas decided to put on another show. It started growing tails. Plural. Not just one tail like you might see in a textbook illustration, but multiple distinct tails with different structures and behaviors. And one of those tails was doing something that only a handful of comets have ever been observed to do. The first tail was spotted in early October, a faint streak extending behind the comet as it approached the sun. This was the classic dust tail, made of tiny particles of rock and ice pushed away from the sun by radiation pressure. Sunlight carries momentum, and when photons hit dust grains, they give them a gentle but continuous push. Over time, this creates a long, graceful tail that curves slightly because the dust particles are following their own orbits around the sun while also being pushed outward. But then in early November, specifically around November 8th, something remarkable happened. Observers in Spain, Frank Niebling and Michael Buchner to be precise, captured images showing not just one tail, but 4 or 5 distinct jet-like structures emanating from the comet. These weren't broad, diffuse tails. These were narrow, almost collimated streams of material shooting out in different directions. It looked like someone had attached rocket engines to the comet and fired them all at once. Now, before anyone gets too excited, this is actually a known phenomenon. It's just rare. What we're seeing are individual jets of gas and dust erupting from specific vents on the comet's surface. As the sun heats different parts of the nucleus, pockets of ice vaporize explosively, creating these narrow jets. The reason we were seeing multiple jets at once was probably because 3i Atlas was rotating, and as it turned, different active regions came into sunlight, triggering different jets. But here's what made it special. The jet structures were remarkably well defined. Usually, cometary jets blur together pretty quickly as the material expands and disperses. But the images from November 8th showed jets that remained distinct over quite a distance. Some astronomers compared the tail structure to Comet C2016 R2, another unusual comet known for its carbon monoxide-rich composition and multiple narrow jets. If 3i Atlas was similar, it might mean this interstellar visitor was unusually rich in volatile ices like CO and nitrogen. And then, just 2 days later, on November 10th, new images revealed that the tail structure had evolved dramatically. Now, there were 2 main features. One was a broad, dusty tail extending about 30 arc minutes from the comet's head. To give you a sense of scale, that's about the same angular size as the full moon. So if you could see this tail, it would stretch across a moon's diameter of sky. That's huge. That's a seriously active comet. The second feature was even more interesting. It was what astronomers call an anti-tail. And yes, that's the technical term. An anti-tail is a tail that appears to point toward the sun instead of away from it. Now, obviously, nothing is actually flowing toward the sun. That would violate basic physics. What's happening is a geometric illusion combined with real physical effects. Here's how it works. Normal comet tails point away from the sun because they're being pushed by solar radiation and the solar wind. But the particles in those tails aren't just moving directly away. They're also continuing in their original orbits. So imagine the comet leaving a trail of dust particles behind it. Those particles spread out into a sheet, a flat cloud of material following similar orbits. Now, as Earth moves in its own orbit, our viewing angle changes. Sometimes we look at that dust sheet edge on. When that happens, the part of the sheet that's geometrically between us and the comet can appear as a spike pointing the wrong direction. It's not really a tail. It's more like looking at the edge of a fan. But there's also a physical component. Larger dust grains are less affected by radiation pressure. They stay closer to the comet's orbital path. So the anti-tail is often made of bigger, heavier particles that haven't been pushed as far away. And because of our viewing angle, those particles appear to form a spike pointing sunward. The anti-tail of 3I Atlas was estimated at about 10 arc minutes long, roughly a third the diameter of the moon. That's still pretty substantial. And the fact that it was visible at all told astronomers several things. First, the comet was producing a lot of dust, enough to create a visible concentration of larger particles. Second, our viewing geometry was just right to catch this rare phenomenon. Third, the dust production had been sustained over time, creating a broad enough sheet of material for us to see it edge on. Now, this is where Professor Loeb couldn't resist weighing in again. In his blog, he noted that the jet structures were remarkably organized and persistent. He suggested, and I'm paraphrasing because I want to be fair to his actual argument, that the jets could potentially be evidence of directional outgassing that might, in principle, be used for course correction if this were an artificial object. He was careful to say he wasn't claiming it was artificial. He was just pointing out that if you wanted to steer a spacecraft using outgassing, this is kind of what it might look like. Most astronomers rolled their eyes at this point. Yes, the jets were impressive. Yes, they were well organized. But that's not unprecedented. Natural comets can produce collimated jets. It happens when gas escapes through cracks or vents in the surface crust. The pressure builds up under the crust until it finds a weakness, and then it erupts in a focused stream. It's like a pressure cooker with a release valve. Nothing artificial required. But you have to admit, the images were striking. Seeing this interstellar visitor, glowing blue, sprouting multiple tails and jets, with that weird spike pointing toward the sun, it did look alien. Not alien as in extraterrestrial technology, but alien as in foreign, exotic, unlike anything most people have ever seen. And that visual strangeness is part of why 3I Atlas captured so much public attention. There's something viscerally compelling about a comet that doesn't quite behave the way you expect. It triggers that sense of wonder, that feeling that maybe, just maybe, there's something more going on here than the textbooks prepared us for. Even if the explanations are perfectly natural, even if every single observation can be accounted for with known physics and chemistry, it still feels remarkable. And you know what? It is remarkable. This is an object from another star system. It formed somewhere else, under conditions we can only guess at, around a star we may never identify. It carries chemical signatures from that distant environment. And now it's here, putting on a light show for us, broadcasting its composition and activity patterns across the electromagnetic spectrum for anyone with a telescope and a spectrograph to see. The color changes told us about its layered structure and radiation history. The multiple jets told us about its internal composition and activity patterns. The anti-tail told us about the geometry of our observation and the size distribution of dust particles. Every single piece of data was another clue, another piece of the puzzle, Another small insight into how comets work, not just in our solar system, but throughout the galaxy. And the observations were far from over, because 3I Atlas was now approaching the most critical part of its journey. On October 29th, it would reach perihelion, the closest point in its orbit to the Sun. That's when things would really heat up. That's when the true test would come. Would this visitor from the stars survive its close encounter with our Sun, or would it break apart, torn to pieces by tidal forces and thermal stress? And what would that tell us about its structure and composition? The answers were coming, and they would surprise everyone. Before we dive into what happened at perihelion, we need to talk about something that most people don't realize about interstellar objects. This comet didn't just travel through empty space for millions of years. It was being transformed by one of the most powerful forces in the galaxy: cosmic radiation. Out in the void between stars, there's no protection, no atmosphere, no magnetic field, just raw exposure to galactic cosmic rays, protons, and heavier atomic nuclei accelerated to nearly the speed of light by supernova explosions. And they don't just pass through objects, they slam into them, breaking apart molecules, rearranging atoms, fundamentally changing the chemistry of anything they hit. For 3I Atlas, this bombardment lasted for millions of years, possibly tens or even hundreds of millions. Every single day, cosmic rays were pounding into its surface, breaking carbon-carbon bonds, creating new compounds, building up a radiation-processed crust unlike anything we see on solar system comets. And in November, scientists got confirmation of just how extreme this processing had been. The composition of 3I Atlas was significantly different from typical comets. It had far more carbon dioxide and carbon monoxide than expected. That's the signature of radiation processing. Over millions of years, this process fundamentally alters a comet's chemistry. But here's the wild part. Scientists estimated that the surface might have a radiation-processed crust up to 20 meters thick. 20 meters of materials cooked by cosmic radiation for eons. This meant the surface we were seeing might not represent the original composition at all. The pristine material from the comet's birth star system could still be locked inside, beneath that radiation-baked crust. And that's exactly what perihelion might do. When a comet gets close to the Sun, intense heat can crack the surface crust, exposing fresh material from deeper layers. If 3I Atlas experienced enough thermal stress, that 20-meter crust might crack open, revealing the untouched ice beneath. So October 29th wasn't just a date on the calendar. It was the moment of truth. The comet reached perihelion at 136 astronomical units from the Sun, about 204 million kilometers, roughly between Earth and Mars. Close enough for the Sun's heat to have a major effect, and the effect was immediate and dramatic. 3I Atlas suddenly brightened, its magnitude jumping from around 12 to approximately 9. That's roughly 15 times brighter in a very short period. That kind of sudden brightening usually signals a major outburst, either from fresh ice exposure or the comet breaking apart. Telescopes tracked the comet during this critical period. The images showed something beautiful and eerie. The comet appeared unusually blue from ionized gases. The solar wind was slamming into the expanding coma with incredible force, creating a glowing blue halo around the nucleus. Spectroscopic analysis detected carbon-2 and NH2, amino radicals formed when ammonia breaks apart. This was new, suggesting that fresh ammonia ice, buried beneath the surface, was now being exposed. The heat from perihelion had indeed cracked the crust. But then came the question everyone was afraid to ask. Did the comet survive? Or did it break apart? For several days, uncertainty hung in the air. The comet was behind the Sun from Earth's perspective, obscured by the glare. All we had were observations from space-based solar observatories, and the resolution wasn't high enough to tell us definitively whether the nucleus was intact or had fragmented. Professor Loeb jumped on this uncertainty. On November 11th, he asked directly, "Did 3I Atlas just break up near the sun?" He pointed to jets and streamers that might indicate the comet was coming apart. But he also made a more provocative point. If the object remained intact after perihelion, that would mean it was structurally very robust. More robust, perhaps, than a typical fragile comet nucleus. As the comet emerged from solar conjunction and became visible again, telescopes turned toward it. And what they found was both reassuring and intriguing. The comet was still there, still intact, still active. The nucleus appeared to be a single body, not a cloud of fragments. But it had changed. The brightness stabilized at magnitude 11 or 12. The color shifted to whitish blue, and those multiple jet structures were even more visible, suggesting thermal cracking had opened new vents on the surface. The survival of 3I Atlas told us something important. It wasn't just a loose pile of rubble. There was structural integrity. And that 20-meter radiation crust probably helped, acting like a protective shell that saved it from destruction. But now, as 3I Atlas moved away from the sun, another mystery emerged. Scientists started asking a different question. Not whether the comet had survived, but whether it had changed course. Because when you pass that close to the sun, gravity and radiation pressure can alter your trajectory. And if the trajectory changed in unexpected ways, then maybe Professor Loeb's questions about artificial propulsion might need to be taken more seriously than anyone wanted to admit. When 3I Atlas passed close to the sun, something remarkable happened. The sun's gravity bent the comet's path, but it also bent the light coming from the comet. Scientists measured this gravitational lensing with incredible precision, about 1.75 arcseconds, just as Einstein's equations predicted. But then came the surprise. The comet's actual trajectory deviated from predictions by about 4 arcseconds. In the precision world of orbital mechanics, that's significant. The most obvious explanation is radiation pressure. Sunlight pushes objects, and for something as light as a comet, this can noticeably affect the orbit. Combined with asymmetric outgassing from those organized jet structures, the deviation was well within normal expectations. Professor Loeb, of course, had a different take. He pointed out that those well-defined jets might not be entirely random. What if the outgassing pattern created a net force in a particular direction? That could alter the trajectory in ways that might look suspicious. The mainstream response was clear. Asymmetric outgassing is common. Comets have irregular shapes and surface features that channel gas in particular directions. It's been observed in dozens of comets. Nothing unusual here. But here's the thing. We'll probably never know for sure. 3I Atlas is leaving. By December 19th, 2025, it will make its closest approach to Earth at 1.8 astronomical units, about 269 million kilometers. By March 2026, it will cross beyond Jupiter's orbit. And by the early 2030s, it will leave the planetary region entirely, vanishing back into the cosmic ocean from which it came. If you're watching this in late November 2025, you have a chance to see 3I Atlas yourself. With a telescope of 80 to 150 millimeters aperture, you can spot it if you have dark skies. Right now, it's in the constellation Virgo, visible in the pre-dawn sky about 90 minutes before sunrise. The best time is in the last weeks of November. Watch out for the moon. November 19th has a new moon, perfect dark skies, while December 4th's full moon will wash it out completely. You'll see a small, fuzzy glow. Nothing spectacular. But think about what you're really seeing. An object from another star system that traveled for millions of years to reach this moment. That's a connection across space and time that transcends the visual appearance. Let me address some common questions. Is it dangerous? No. The closest approach is 269 million kilometers, almost twice the Earth-Sun distance. Zero chance of impact. Is it really from another star system? Yes. The hyperbolic trajectory confirms it. Could it be an alien spacecraft? Almost certainly no. Every observation, water vapor, carbon dioxide, dust, coma, tails, all consistent with a natural comet. What makes 3I Atlas special? It's the third confirmed interstellar object, and we've had more time and better instruments to study it than previous visitors. We've learned that interstellar comets can survive million-year journeys, that cosmic radiation creates thick crusts on these objects, and that the basic building blocks of planetary systems are similar across different stellar environments. Here's my take after following this story. 3I Atlas is exactly what it appears to be. A comet. A natural object ejected from another planetary system billions of years ago. Not an alien spacecraft. But that doesn't make it any less amazing. What we're witnessing is a natural process happening throughout the galaxy. Stars form, planets form, comets form, and gravitational interactions send them wandering through space. The galaxy is full of these drifting ambassadors from distant suns. 3I Atlas reminds us that we live in a connected universe. Matter moves, spreads, mixes. Over billions of years, how much material has been exchanged between star systems? How many organic molecules have been scattered across the galaxy by comets like this? Some of our own stardust might have come from other star systems. So if you get a chance to see 3I Atlas in the next few weeks, take it. Think about the journey it took to get here. This might be the only time in human history we observe this particular object. It came from the darkness, passed through our sunlight briefly, and now returns to the darkness, never to be seen again. Before I wrap up, if you found this story fascinating, please subscribe to this channel and turn on notifications. Space science moves fast, and I want to keep you updated on the latest discoveries. Give this video a like if you enjoyed this deep dive, and let me know in the comments. Do you believe this is just a natural comet, or is there still room for doubt? Share this with anyone who loves space and cosmic mysteries. 3I Atlas is out there right now, carrying its secrets away from us. We had our moment with it. We learned what we could. Its story, the questions it raised, the wonder it inspired, those remain with us. Maybe someday another civilization will detect it passing through their system and wonder the same things. That's the legacy of 3I Atlas. Not just the scientific data, but the reminder that we're all part of something bigger, connected by the matter that flows through the galaxy, by the curiosity that drives us to look up and ask why. Keep looking up. Keep asking questions. The universe has many more visitors in store for us. Until next time, clear skies, everyone. And don't forget to look for our visitor while you still can.